Okay, we're almost done with this lesson, this review. Okay, students love to see this. Now I'm actually going to write out the multiplication here so they can see. You've got 1/3 times 12 minus 1/3 times 6x equals, and I'll just write it out over here just for fun, 2 times 3 plus 2 times 5x. This is what gives students a little bit of issues. I want you to remember when you're multiplying a fraction with the whole number, you can turn that whole number into a fraction by putting it over 1, even when it has a variable. And you can just multiply numerator and numerator, and denominator and denominator. And hopefully you notice that reduces, but I'll continue. Numerator times numerator, denominator times denominator. And then 6 plus 10x. Okay, now, every time you multiply fractions, you should make sure to check to see if they reduce. 12/3, hopefully you recognize, reduces to 4. 6x over 3, hopefully you recognize, reduces to minus 2x. And bring the other side down. Okay, now, this is the first one I've had that I have a variable on both sides. And your goal is to get your variables on one side and your constants, the ones without variables, on the other. Does not matter which direction you take them. Most teachers teach you to take the smaller variable to the larger variable. So that's what I'll do. I have minus 2x, so I'll add 2x to both sides. On the left-hand side is only left a 4. On the right-hand side, I still have 6 plus 10x plus 2x is 12x. Now I'm going to move this 6 to the left because I've got my variables on one side. I only have one variable. Need to move my constants to one side as well. So I'm going to subtract 6. So I'm going to have 4 minus 6 is negative 2. That goes away, equals 12x. Okay, then I'm going to divide by 12. And be careful, remember to always divide by the coefficient of the variable. A lot of students would just divide by negative 2 here, and then they would get the wrong answer. Okay, so now my variables alone, x is by itself, and I can make it x equals, although it's equals x. And I've got, 12 won't go into negative 2, so I've got negative 2 twelfths. And that's a fraction. I need to check that fraction to see if they have a common factor. They do, so I need to divide both of these by 2. So my answer is going to be x equals negative. Remember that neither the numerator nor the denominator is a negative number. So a negative 1, 2 divided by 2 is 1, over 6. Negative 1/6 is the answer. I'm going to let you trust me that that's the solution. Okay, let's look at this last thing. Sometimes you encounter problems that are strange. All of the ones that we just encountered, all of these have one solution. The only answer that works for number 1 is 4. The only answer that works for 2 is 15, so on and so forth. I want you to look at what happens when you encounter a no solution problem. When you look at this problem, we would distribute first. And we would move this smaller x to the larger x, but hopefully you see that they're the same size. So when you move them, you're left with 6 equals 4. Is that true? No, that's false. That can never be true. 6 will never equal 4. So this solution to this problem is actually no solution. There's no value of x that would ever work for that problem. Now I want you to look what happens here. You have 3x plus 9 equals 3x plus 9. If you don't notice something redundant that you just said or that I just said, then you'll see when I do this, I'm going to move the x's, and again they're the same size, which means they go away, and I end up with 9 equals 9. Is that true or false? That's true. 9 is always equal to 9. So what that means is no matter what you would select for x, it's going to always work. It's going to be a true statement. So there's an infinite amount of solutions that will work for this problem. Infinitely many solutions. Let me show you. If you put 2 in here, 3 times 2 is 6. 6 plus 9 is 15. If you put 2 here, 2 plus 3 is 5. 5 times 3 is 15. So 2 satisfied that. Let's put negative 10. 3 times negative 10 is negative 30. Negative 30 plus 9 is negative 21. 10, negative 10 is what I said. Negative 10 plus 3 is negative 7. Negative 7 times 3 is negative 21. So no matter what you would select, that solution would work for this problem. So that's why there's infinitely many solutions. Hope that helps.